Thousands of years ago, as people began to wonder what the world was made of, many people began coming up with their own theories. A man named Thales believed that the basic unit of life was water. Other theorists, such as Anaximenes and Empedocles, thought that life was based around air or fire. These ideas were many scientists' base of understanding for life for many years. During this time, there were many other important discoveries, such as the Pythagorean theorem, which was discovered by Pythagoras. He thought that the world could simply be explained through mathematics and logic, and that no science was needed.
Democritus was the first to dream of the atom. He thought that the atom was something that could not be cut or split up and was a solid, hard, and compact mass. Democritus's idea of the atom is similar to that of the modern-day golf ball. Solid, hard, and cannot be destroyed.
I can't destroy it. Socrates and Plato disagreed with Democritus. They did not believe in the atom.
Those atoms.
Similarly, Aristotle rejected the idea of the atom and thought that the basic substance or elements could be divided endlessly and you would never get anything else.
He thought that gases were made of tiny corpuscles with empty space between them. Boyle's idea would look similar to the grapes in this container that are separated by empty space. See the empty space between the grapes? That was Boyle.
Newton thought that the basic units of life were something impenetrable, solid, and full of massy particles. The particles in a hacky sack work together like Newton assumed the particles in an atom.
As ideas and technology developed, many scientists began to expand off of each other's theories. Dalton, a new scientist, based many of his ideas off of Newton and Democritus when he assumed that the atom was hard like a billiard ball. Dalton realized that you could weigh atoms using ratios. He figured out that if you weighed equal amounts of different elements, he could calculate their weight ratio to one another. He eventually prepared a table of atomic weights. Furthermore, he believed that atoms could not be created or destroyed, and that chemical reactions are just rearrangements of atoms. He was the first to understand the difference between a mixture and a compound.
Finally, the electron was discovered.
Yay.
Thomson was the genius who made this discovery. Thomson explored the idea that the atom is the smallest particle of an element that can still be defined as that element. He suggested that the tiny particles were coming from the inside of the atom and that therefore it was not completely solid. Thomson thought that the negatively charged electrons must be in a cloud that has a positive charge. This tomato represents how Thomson viewed the atom. The seeds represent the electrons surrounding the
Using
center.
Thomson's ideas, Rutherford suggested a new model for the atom where the tiny charge must be concentrated in a tiny volume. This meant that the electrons orbited around a dense nucleus where the positive charges were concentrated. Rutherford's ideas can be shown by this kiwi, which has tiny particles around a dense center. See the kiwi?
This apple represents our next scientist ideas. Bohr thought that the electrons must orbit around the nucleus and fixed energy levels. As you can see, this apple has seeds in a set position around the core of the fruit. He thought the energy must be given out when excited electrons fall from the high energy level to a low one. This model of the apple shows the seeds in the excited
Schrödinger discovered the model that is commonly used today. He devised a mathematical equation to describe the behavior of an electron known as the quantum mechanical model. This model shows orbital patterns in a 3D format, like this. It's 3D.
Ooh, 3D. Technology and new discoveries are being made every day, and we can't wait to see what the future has in store for the atom.
Cannot wait. Oh my gosh.